Imagine a computer program, right? Directing a military strike. And when a commander asks why it chose that specific target, the machine just, shrugs. It has no answer.
Right, which is terrifying. Because for a long time, that was the reality of military AI. It operated in total secrecy.
Data goes in, some mysterious math happens, and a target comes out.
Exactly. And when you are dealing with operational systems, making, critical real-world decisions, a black box is a massive liability. You can't just cross your fingers and hope the underlying math is right.
No, absolutely not. And that tension is exactly what we are exploring in today's deep dive. We've got a really interesting stack of sources today.
We do, yeah.
There's an article by Christopher Coleman, and we're looking at that alongside some declassified research and theses straight out of the Naval Postgraduate School.
Right.
So our mission today is to track how next-generation AI is evolving from just, guessing what's happening right now to autonomously simulating the future, and why forcing these systems to show their work is really the only path forward.
Yeah, and to understand this shift, we really have to look at the limitations of historical AI first. Because historically, computing was basically just about collecting data.
Just gathering it all up.
Right. And then early machine learning came along and classified that data. And eventually, AI began prioritizing it. But the fundamental goal of all those early methods was really simply understanding the present moment.
So it's just answering, what is happening right now?
Exactly. Just taking a snapshot.
Okay, so if early AI was essentially just a data cruncher telling us what was happening, when did we realize that that wasn't going to cut it for tactical operations?
Well, the shift really crystallized around 2019. There was a researcher at the Naval Postgraduate School named Jeffrey Grooms, and he wrote a thesis looking at AI for automated battle management aids.
Okay.
Because in a tactical environment, the sheer volume of chaotic information makes it impossible for a human to manually evaluate every single option in real time.
Right, because the battlefield isn't static. It's not just, here's the enemy. It's like, here's the enemy. The weather just changed. Our communications are jammed, and we're low on fuel.
Exactly. So the system had to move beyond basic classification. Grooms realized the machine needed to process all that chaos to actively identify alternatives and actually support human decisions.
I mean, it's been the difference between a weather app just telling you it is raining versus an app that actively reroutes your drive, right? Like adjusting for flooded roads and traffic accidents as they happen in real time.
That's a perfect analogy, yeah.
It's moving from what is this to what do we do about this? But wait, if the storm keeps shifting every 5 minutes, doesn't the AI have to constantly calculate new routes?
It does.
Wouldn't generating that many alternatives just totally overload the system?
Yeah.
Or the person looking at it?
Yeah, and that exact problem became the catalyst for the next massive leap. So by 2022, researchers launched a project called WR.
Which stands for, let me check my notes, Wargaming, Real-Time Artificial Intelligence Decision Aid.
Right, quite the mouthful. But they realized predicting the present just wasn't enough. They needed to simulate futures.
How does an AI war game exactly? Is it just running math equations in a giant spreadsheet or something?
No, it's using game theory and multi-agent simulations.
Yeah.
So imagine throwing a bunch of different AI agents into a virtual sandbox.
Oh, okay.
One agent is playing the role of the enemy trying to cut off supply lines.
Right.
Another's playing the weather,
Yeah.
and a third is your fleet trying to advance. And they constantly battle each other at lightning speed.
Wow.
So instead of asking what is happening, the system asks, what happens if we do this?
Yeah.
And then it just plays out the consequence.
Okay, but I have to push back on the utility of that for a human commander.
Sure.
If a system is constantly simulating dozens of multi-agent futures in the background, aren't we just replacing standard battlefield information overload with AI-generated information overload? I mean, you're just dumping a million simulations onto a human supervisor. That sounds awful.
You've just hit on the core architectural bottleneck of this whole concept. Because if you bury a human operator in simulation logs and confidence scores, you haven't helped them at all.
No, you've just given them a new full-time job reading logs.
Right. So the researchers realized that human trust isn't a communication issue. It's an engineering problem. Trust actually has to be built into the system's architecture from the ground up.
So how do you engineer trust without drowning the operator in data?
They developed a concept called Warden. Warden basically acts as a control plane. Think of it as like an air traffic controller for the AI's brain.
Okay.
It sits above all the individual simulation models and agents. Its sole purpose is to observe the system and expose the state of the machine in a way a human can actually digest.
Oh, I like to think of Warden like, knocking down the walls of a restaurant to create an open kitchen.
I like that, yeah.
Instead of just getting a plated meal handed to you, which is like the final AI output, Warden lets you see the chef throwing out bad ingredients, choosing a specific spice, making decisions. You actually see how the meal was made.
Exactly. And it shows the operator exactly what data the AI trusted, what it threw out, what actions it has already initiated, and crucially, what moves are still reversible.
Oh, that's huge.
Yeah, it handles the orchestration so the human isn't overwhelmed but stays fully informed.
Which applies way beyond naval fleets, by the way. I mean, in everyday business, if an AI workflow analyzes customer data and drafts a strategic action plan for you, just seeing the final plan isn't enough anymore.
No, not at all.
You have to understand the interdependencies. You need to know why the machine chose that specific path if you want to effectively team up with it.
And that is the critical difference between an intelligent model and an intelligent system. The underlying wargaming models can remain incredibly complex, but the architecture around them, that open kitchen, it must be completely legible to the human.
All right, we finally get to see the chef at work, but, it leaves me with one final thing to ponder about all this.
All right.
Well, as these control planes perfect the ability to simulate and evaluate countless future realities simultaneously, will human intuition eventually be viewed as a liability?
Oh, wow.
I mean, we might be building these systems so humans can make the ultimate decisions today, but I just wonder if one day we'll just become mere spectators of the machine's optimized reality?